Good morning, everyone. Yeah, my name is Els Baert. I work for NetComm Wireless. And for those of you who don't know who NetComm Wireless is, we are a company that provides solutions to connect the last part of the network. So that goes from modems in the home with improved Wi-Fi capabilities to connect everything inside the home, but also DPU type of solutions, including a DPU with G.fast and a reverse power unit. And then lastly, also fixed wireless solutions. And today I was asked to talk about fixed wireless, mainly because we focus on connecting where others might see things that are too hard to connect. And traditionally in the past, the type of solution that was used for those connections that are too hard was fixed wireless. So we have a lot of experience in fixed wireless, and that's actually where I want to focus on today. So in this presentation, I want to show you, it's not going to be as technical as the previous presentations I've seen, because I want to show how you can use fixed wireless to meet government targets and to expand your coverage. And I think fixed wireless is quite new for, so my background is in fixed networks as well, and fixed wireless is kind of a new tool in the toolbox to do fixed broadband services. And I think it's important that we all understand what the differences are and what the use cases are and how fixed wireless can actually help you expand your footprint and provide broadband services, and how less can actually mean more. So this might be a bit of a controversial statement. Is the race to a gigabit outdated? So the reason that I put it out there is that the last couple of decades, we mainly focused on getting more out of the network, upgrading the network to higher and higher speeds. And today we have the technologies available to provide gigabit services to the home. And it's great that we can do that, and it's a great marketing tool, and it's definitely something that we need to focus on and keep doing. On the other hand, if you look at the willingness to pay from the end users, the incremental ARPU we can get from upgrading end users from 100 megabits per second to 1 gigabits per second is actually fairly limited. Not many people want to pay a premium to get 1 gigabits per second in their home. However, connecting them from 0 to barely nothing to speeds of 30, 50, or 100 megabits per second can actually increase your ARPU quite significantly. And if you take the statistics of the European Commission, there's actually quite some opportunity out there that actually can help you grow your revenue and connect those end users. So 3% of households don't have a connectivity at all. So that is mainly, we talked about it yesterday a little bit, the rural areas and the hard to connect. 25% of households don't even have access to 30 megabits per second, which is nowadays kind of being seen as the basic that you need. And only 50% of households are connected to 100 megabits per second. So there's quite some opportunity there, and this is also something that governments have recognized. So broadband is not just some nice to have anymore. It's really something that stimulates economic growth, that helps the society to really be successful. So we kind of put it next to water, sewage, electricity, plumbing. This is really something you can't just, it's not just some nice to have, it's really a basic need for everyone in today's society. And that's why you see, and I think Australia was the first actually to recognize that and to put a target of connecting 100% of the population. In Europe, we started with 90% and in the US as well, but now they also reviewed those targets to connect absolutely 100% of the network to allow for that, that digital economy and digital society and stimulate the people. The question now is how are we going to do that? And it's great if you're the incumbent provider and you have copper lead-ins or cable lead-ins, and I think we've, and Paul always explains it very, very nicely, how the copper is actually still very useful to upgrade from G.fast, now MG.fast, and it's definitely the right strategy to, if you have those lead-ins, to reuse those lead-ins with the new technologies that are available. The thing is, and yesterday we talked about competition as well, is what are you going to do if you don't have the lead-ins? And then we see all these municipalities and competing companies try to put in fiber. But we've seen that fiber to the home can be fairly expensive. You don't know if the end users are going to take on the service. And that's actually where the evolution of cellular technology now makes it possible to provide a cost-effective solution to offer fixed broadband services if you don't have a lead-in available today. So if you look at the evolution of cellular technology, we started with the first generation, which was mainly we just wanted to make phone calls on the go, just the mobile phone, let's just have a phone call. Then we added in basic text messaging, and then with 3G there was a basic internet connectivity possible, but it's only with 4G and the coming up of the smartphones, where we actually really had a decent mobile broadband type connection on our phones. And that's also from the start, and you can see we've had a few generations of 4G, right? So the standard kept on evolving, first 50 megabit, 300 megabits, now gigabit speeds are possible. Obviously, this is shared, so it's more similar as a cable similar to a cable network than to a copper network. It's a shared medium, and you share it over all the mobile phones that are connected. So with these kind of speeds, suddenly you have, and many operators around the world are doing it, you can actually very quickly connect end users to a fixed broadband service as well. And especially if you look at rural areas. So in a mobile network, how does it work? So you have certain frequencies, and you have to buy the frequencies that you want to use for your 4G network. Now, typically you buy the frequencies for a whole country. And then in the rural areas, you actually don't have so many people connecting. So you only have a few people with a mobile phone that are connecting to the base station. So if you look at the top left there, there's actually a lot of frequencies that you own but are underutilized. And those frequencies you can actually use to to connect the homes, basically. Put a modem in the home and connect them to fixed broadband services. So instead of running a fiber all the way to the home, where in rural areas it is really expensive, sometimes you have hills, it might be really difficult, and you don't have a lot of houses in a certain area, then actually this is a very quick and easy way to offer fixed broadband services. In suburban areas, you still have a bit of frequencies available sometimes, so it's another possibility to just quickly expand your addressable market. You can offer your services in those areas without actually having to put in a lead-in. When the end user takes on a service, you can install a modem at their home, they connect to the base station, and they have a fixed broadband service. In urban areas, the density of people using the mobile network makes it really challenging. You can do it, but it's really not going to provide the right level of quality that end users want from a fixed broadband service. And that is where, and that's also why with 5G, and we call it the road to 5G, because it's actually a few, and I'll come back to that in the next slide, a few of the technologies already were introduced in 4G. With 5G, this suddenly becomes available. And why is that? So it's because of these 5 new things that are being added to the standard. And the first 2 are actually already added to the 4G standard. So you can already do that on 4G. So it's not that we have to wait for 5G to come along to do fixed wireless. You can perfectly well do that with 4G. So the first one is beamforming. So traditionally, what you have is you have your base station, and that kind of so your cell gets divided in 3 sections. So you can reuse the same spectrum 3 times. With beamforming, you're really going to form a beam which is a lot narrower and focused on your end users or your homes, which actually allows you to reuse the spectrum a lot more, which gives you more capacity, which means that you can connect more end users. Massive Mimo. So we already had, I think most of the networks already have 2x2 Mimo. 4x4 Mimo is widely available. And Massive Mimo is even, will allow actually for even more capacity, more end users to be connected. It basically means that you have multiple antennas transmitting and multiple antennas receiving. And because of the reflections that you have, each signal will have a different path to follow and a different latency, basically, which means that you can distinguish the different signals from the different antennas and therefore have more bandwidth if you put different signals on the different antennas. So these things are already possible in 4G. With 5G, what additional functionality are we going to get? First of all, new frequencies. And yesterday we had a session around millimeter wave, and millimeter wave is definitely going to play a very, very big role in that. But it's not only going to be millimeter wave, it's also going to be mid-band, and some are even going to use 5G in the lower bands. So the new frequencies that will be auctioned and will become available will allow to have more bandwidth, and therefore you can have more users to the same base station. The fourth one is new radio, which is a new technique of analyzing the signals, and which basically gets you more out of your spectrum. And then the last one is network slicing, which is a virtual split of your network, which allows you to virtually have different networks, but the same physical infrastructure, which actually means that for you can have certain kind of quality of service for your mobile users, and then maybe other type of quality of service for your fixed broadband users, and then in the future we'll have IoT and all other types of applications as well. And this is actually going to be fairly important, because one of the things that you have to understand, and which might be new for people that are have been embedded in a fixed network in the past, is that a mobile network is built differently. So in a mobile network, you only have visibility and control till the base station. And then the end user, they buy their phones, the different brands on the market, they choose it themselves, they either upgrade the software or they don't. They kind of have responsibility of their own over the mobile phone. Also in a mobile network, we kind of accept that now it's going to work great, I move around, it's not going to work that great. It's a very volatile type of connection, and we accept that, and that is fine. We know that that's going to be the case. In a fixed broadband connection, that's not what we expect. We expect a lot more. And first of all, we expect reliability. We want to know what we're going to get, and we want to get it at all times. So therefore, it's actually quite important that if you use fixed wireless, that the modem in the home is fixed. So once you install it, that the end user is not going to move it around, because then you don't know what you're going to get. The second one is speed. So the new developments are actually going to help with that. But the other one is that, especially with the higher frequencies, it's going to be even more important, is that you need a proper line of sight. The better the line of sight you have, the higher the signal-to-noise ratio is going to be, and the higher QAM modulation you can actually use, and therefore also higher speeds, and you can basically get more out of the same base station. And then the last one, might actually be the most important one, is that if something goes wrong, end users will call you. In a mobile network, we don't really do that. If it doesn't work, we wait 5 minutes or we move around and we see what happens then. But in a fixed broadband network, if something goes wrong, they're going to call you, they want you to help them. So that means that you actually need the right management and diagnostic tools to actually also see what's happening with that end device. And that's what we call extending the trusted zone. So you really want to have visibility up until the home. You want to have control over how and where the device is installed. You want to make sure that the line of sight is optimal and that you have the right diagnostics tools, that when an issue does occur and the end user does call you, that you have visibility and you can actually troubleshoot the network. So once you have a fixed wireless network in place, or even a mobile network, you can really expand as you grow, and the possibilities are quite endless. So maybe you start with a mobile network where you only connect your mobile end users. Like I explained, if you can actually add the homes to that with fixed wireless, and with the network slicing in 5G, you can actually virtually split that. And then once you have that, actually, if you think about it, you can connect anything that wants to be connected. So the first one would be machine to machine. Traffic lights, cameras, billboards, and that's really also where the most of the money is going to be for business services. Businesses are evolving to a more digital kind of connectivity, and they might have these kind of applications where they really want a reliable type of connection. But it's not possible to run a wire. For example, to a billboard, it's not that easy to just run a fiber to the billboard. While you can actually put a wireless modem in there and connect it to the 4G or later the 5G network. If you need more bandwidth, you can upgrade your base station to 5G, and then in the future you can even add additional base stations for even more capacity or filling gaps. So fixed wireless is really an exciting technology to add to the mix to offer fixed broadband services. And I just put here a few use cases because the possibilities are endless. So typically it has started with rural broadband, and that's mainly to meet the government targets of really connecting everyone. And yesterday we talked about it when there's water, there's hills. Sometimes it's just easier to do a fixed wireless connection, but also where you don't have the lead-ins and fiber is too expensive. You can even do it in suburban and rural and urban areas. And then once you have that, you can do signage, automation, healthcare, infrastructure. You can basically connect anything to generate new revenue streams. So that was really it from my side, so I'll take any questions if possible.